So let's pick up a problem. Given a problem that is x of n is 1 comma 1 comma 1 comma 1, calculate 4-point FFT using DIT FFT method. Okay, or DIT FFT butterfly structure. Okay, so DIT it is, right? So I made a mistake here. So it's DIT FFT method. Okay, decimation in time. So that is what we are looking at. So where this is a 4-point, so first thing we'll have to arrange since it's a 4-point, we will arrange it as the even terms first, x of 2, and then we'll have the x of 1 and x of 3. Okay, have a good spacing so that the things become cleaner. So then I know that we the way we go about it is we have to first go through a, let's say, n by 2 point DFT. We know that, right? So this is how we go about it, right? So we input it to a n by 2 point DFT. N by 2 is n is 4 here, right? So here your n is 4, so this n by 2 point DFT will be 2 point DFT. Okay, and then we input it to a 4 point DFT, right? So how we do this is we input the output to a 4 point. That's your DIT FFT structure. So here this will be like doing a 4-point. Yeah, so this will be doing a 4-point DFT, and this will be like going out. Okay, so this is 4 points. So you'll get x of 0 in order, x of 1, x of 2, and x of 3. So DIT, what we do is, this is the time domain side. So time domain side, so it's a decimation in the time domain. So this is not in order. Okay, if you see, and this here in the frequency domain, it is in order, the outputs that you get. So let's start with the problem. So we will draw the butterfly structure first. So first thing, right, we know the 2-point structure for a 2-point butterfly structure. So let's draw this: x of 0, x of 1, x of 2, x of 1, and then x of 3. We have this now. So first let me take a 2-point DFT of this. Okay, so let's just say that this is your 2-point DFT. For this, we'll draw this structure here. Okay, so we will have, this is your x of 0, these ones are your points. So we know the 2-point DFT structure, which is this guy goes here with a W0 of 2, and this guy comes here with a W1 of 2. Okay, so this is how your DFT structure is. We know that I have told you about scaling. So this is getting multiplied with 1, this is getting multiplied with 1, right? So same structure will get repeated here. Same structure will get repeated here. So this is W0 of 2, this is W1 of 2. We know the formula here is x of k equal to g of k plus wk of n into h of k, right? And for this is, let's say, x of k, we can write it any right now, p of k, or let me just, to be clear, g of k is something like this, right? G of k is p of k plus wk of n into q of k. Okay, so n is 2 in this case. Okay, it's a 2-point structure, so w0 of 2, w1 of 2. So this is the first structure that you get. This does the 2-point DFTs. This guy does a 2-point DFT, this guy does a 2-point DFT, like n by 2. This is a 2-point DFT. Then you have the next structure which is coming in, which is actually doing a 4-point DFT, right? So let me just extend this line. So this guy gets extended, this guy gets extended, this one and this one. Okay, so now what you have is, this is your 2-point DFT outputs. I'm just buffering it for some time. Okay, so now this one, let me extend it here to this particular point. Let me extend it here, this guy here, this guy here, and this guy here. Okay, so this way these have to be now outputted using a 4-point butterfly structure. Okay, so this is a 4-point structure. Now this again has to be expressed the same way. So what I will do is, this guy gets added to this point. This is your w0 of 4. This is a 4-point structure, so n becomes 4 now in this case. So this guy gets added to this particular node here. This is w1 of 4. This one gets added to this node here. So this is w2 of 4. Okay, and this node, so let me just have this one first one. Okay, so this one is your w2 of 4 and this one is w3 of 4. Okay, so this is gets added here, this branch gets added here, this branch gets added here, this branch. So now if you look at this, right, we can pre-calculate this. So let's say that let's say your w0 of 4, w0 of 4 we know is 1, w1 of 4 is minus j, w2 of 4 is minus 1, and w3 of 4 is plus j. Okay, we know this, guys, these ones, right? So now we just have to express this. And another thing is, you don't have to calculate w1 of 2. We can just say that when you say w1 of 2 is same as w2 of 4, right? We are actually multiplying numerator and denominator by 4. So this is actually equal to minus 1, right? So let's do this. So we know that this is value is 1, this value x of 0 is 1, this is 1, this is 1, and this is 1, right? So 1 plus this is equal to 1, this is equal to minus 1, this is equal to 1, this is equal to minus 1. We know that, right? So 1 plus 1, this gives me 2. Okay, let me write 1 plus 1 is equal to 2, 1 minus 1 is equal to 0, 1 plus 1 equal to 2, and 1 minus 1 equal to 0. So the output here is 2, 0, 2, 0, right? So how many multiplications are involved here? The multiplications involved here are this guy here, 1, 2, 3 and 4 complex multiplications, right? So this is the first stage. So second stage, there will be 2 stages here, because it's a log 2 of n number of stages. So log 2 of 4 is 2, right? N is 4 here. So yeah, so now let's do the second one. So this 2 comes here, this is 2, so we know this is 1, this is minus j, this is minus 1, and this is j, right? So 2, this is 2 plus 2, this becomes 4. Okay, so this output here is x of 0 is 4. Okay, this particular point, this is 0 which is coming in here, 0, and this is 0, 0 minus 0 into minus 0 plus 0 into minus j, which is equal to 0. So this will be 0 here. So here we can just write this as 2 plus 2, this is 4. Okay, this is 0. So what you have here is x of 1, capital X of 1, which is 0. Then you have 2, which is coming in here at this branch. It is 2 minus 2, right? 2 minus 2, which is equal to 0 again. So x of 2 is a 0. Okay, and here again, if you look at this, right, this is a 0 which is coming in, and this guy is 0. So 0 plus j into 0, which is a 0, which is equal to 0. So this is x of 3, which is a 0 again. So you have your DFT calculated. So if you look at the number of multiplications, 4 multiplications in this branch and 4 multiplications in this branch, right? This guy here, 3 and 4. So this is a 1 anyway. So 4 plus 4, right, 8. So 4 into log 2 of 4, so that is 8, right? So that's the number of multiplications you have. So this is how you calculate your 4-point DFT. Okay, so let's move to a 8-point now. Okay,